Okay, this lesson is called Inequalities in One Triangle. So let's take a look. First, we're going to talk about a comparison property of inequality. This is something that we're going to use further on, but it kind of is common sense. If A equals B plus C, and C is greater than 0, so C has to have some value, then A must be greater than B. In other words, if C is 0, then A would equal B. But if we add something greater than 0 to that, then our A has to be bigger than B. And we're going to use that in the next group of things that we're going to do. So let's carry on here. Okay, so corollary. Corollary to the triangle exterior angle theorem. So the measure of an exterior angle of a triangle is greater than the measure of each of the remote interior angles. Now let's back up. Remember what the original triangle exterior angle theorem was. We had a triangle, and if we had an exterior angle, we said that the measure of angle 1 is equal to the measure of angle 2 plus the measure of angle 3. So that was our original triangle exterior angle theorem. Now we're saying, because of the theorem that we just looked at, the property of inequalities, if we know that measure of 2 and 3 are both more than 0, which we can tell, then we can say that if angle 1 is an exterior angle and 2 and 3 are remote interior angles, just like the drawing we have here. Okay. Oops. Sorry. So now we can say that since the measure of angle 1 equals measure of 2 plus 3 by our previous inequality property on the last slide, we can say that the measure of angle 1 has to be greater than the measure of angle 2 because it equals 2 plus 3 and 3 has value. And the measure of angle 1 has to be greater than the measure of angle 3 because 1 equals 2 plus 3 and 3 has a positive value. So combining the theorem or the property on the previous page with our triangle exterior angle theorem, which says this, we can make the conclusion that the exterior angle is greater than either of the remote interior angles. So let's talk about our theorem now. Theorem 5.10. If two sides of a triangle are not congruent, then the larger angle lies opposite the larger side. So if xz is greater than xy, then the side opposite xz, which is the measure of angle y, has to be greater than the angle opposite xy, which is the measure of angle z. So the longer side gets the bigger angle, the two red ones. The shorter side gets the smaller angle, the green ones. Okay. Oops, so I think that's all we had to do for that one. Yeah. All right, theorem 5.11. If two angles of a triangle are not congruent, then the longer side lies opposite the larger angle. So again, if we have an angle, A here, that is greater than B, then side BC is going to be greater than the other one. So if B is smaller, AC is also smaller. So again, the same thing but in reverse. If the angle is bigger, the side opposite is larger. And if the angle is smaller, the side opposite it is also smaller. So let's take a look. Yeah, so let's back it up a little bit. And so if I give you a triangle using the two theorems we just looked at, if I give you triangle ABC, and I say that this is 4, this is 7, and this is 10, you should be able to tell me the order of the angle measures. So angle C is going to be the smallest, it is less than. Angle A is the next smallest, and that is less than angle B, which is the largest. Be careful when you're using angle symbols that the bottom of the angle symbol is parallel with the paper, and your greater than, less than symbols look different than your angle symbols. So the same thing with the angle measures. If I give you triangle ABC again, and I tell you that this is 30 degrees, and this is 50 degrees, and this is 100 degrees, you should be able to tell me that the smallest side is BC, which is less than side AB, which is less than side AC. Again, ordering them from smallest to largest based on the angle measures. Okay. So that's theorems 510 and 511. 512, the triangle inequality theorem. The sum of the lengths of any two sides of a triangle is greater than the length of the third side. And again, this is kind of common sense. If I have a side of 4 and another side of 7, this side cannot be more than 11 because 4 plus 7 added together is 11, and that would not form a triangle. In order for the 4 and the 7 to form a triangle, this side has to be less than 11 units. So for example, can a triangle have side lengths of 4, 6, and 9. So each pair has to be, the sum of each of two sides has to be greater than the third side. So 4 plus 6 has to be greater than 9, that's true. 4 plus 9 has to be greater than 6, that's true. And 9 plus 6 has to be greater than 4. So yes. Let's try another example. Can a triangle have side lengths of 14, 9, and 5? So 14 plus 9 is greater than 5. 14 plus 5 is greater than 9. But 9 plus 5 is not greater than 14, so therefore this cannot be a triangle. This one worked, the second one did not. Okay? The last thing we're going to do with this is to find possible side lengths. So if I have a triangle, if a triangle has side lengths of 5 and 8, what possible lengths well, let me say this another day. What lengths would be possible for the third side? Sorry, it doesn't show up very well over there, does it, for the third side? So I know two things. I've got 5, 8, and then an unknown length. So I'm going to call that x. Well, first of all, I know that 5 plus 8 has to be greater than x. But I also know that 5 plus x has to be greater than 8, and 8 plus x has to be greater than 5. So 13. So x has to be less than 13. X also has to be greater than 3, and x has to be greater than negative 3. Well, if x has to be greater than negative 3 and greater than 3, let's look at our number line. There's negative 3, and there's 3. If it has to be both of those things, then it has to be greater than 3. So we can ignore this. So it's got to be greater than 3, and it's got to be less than 13. Therefore, x has to be greater than 3 and less than 13. That's our compound inequality, and it's between 3 and 13. It cannot equal 3, cannot equal 13, but it can be between the two. And that's it for this section.